Yes, oh my goodness. Yep, I am muted. Scuff. First time? No, it's not the first time. But hello everyone, welcome back to another stream where we try to mix crazy things. So, as you know, usually we do Power World and sometimes science. Oh wait, let me just recheck the stream buddies thing. There you go. Refresh. But yes, as you know, we do science sometimes here, and we also do Pal World. But today we are going to mix the part where where is the heart rate monitor? It's not here on the just breathing screen. I mean just chatting screen. It should be here. There you go. It's now here. I will just adjust it. So today we are going to try and mix these two because I will be using a treadmill while reviewing my lessons. Why? Well, why not? You know, why not? It's crazy what you can do with chemistry. Exactly. Exactly. Wait, is the heart monitor clear enough right now? There you go. I think I can put it here. It's like very in the center. Very, very centered. Okay, there. So, yeah, I sometimes watch, yes, not read. I will be reviewing my mini chemistry and other biochem lessons, biochem and molecular biology lessons, while using this mini walk pad slash treadmill. Why? Because we can. Alright, I will click the button and start it. Let me see. And it's starting. I think it's at 0.6 miles right now. Let me see. Nope. No, 0.5 miles. Ohio, it's at 0.5 miles. Can you hear the mic? Is it clear? Hello, Decipher. The walkpad stream is now working. How do I have my mic set up? It is in front of me. That's what I can say. Okay, so let's start. What is a buffer? A buffer, we know we mix that in the experiments, right? So the grind has started. Yes, this is increasing our lung capacity while also learning. Why is the stream mini? Nah, it's alright. The stream buddy is not working. Can I pause this? Where is it? I want it to work. Yeah, I paused it. Yeah. There you go. Let me just refresh the stream buddies really, really quickly. There you go. Okay, I'll start it again. One more time. Yeah, what is a buffer? It's a solution that resists the changes in the pH. We know that. We put it on our things to maintain it. Have you stretched? Oh, I did not. I just did it. I just went on top of it and then I just did the treadmill. Should I stretch? I can't understand the intricacies of chemistry, but the concept is crazy too, like playing with building blocks of reality. Yes. That's why we're learning it today. But yeah, what is a buffer? A buffer is a solution that what's it? It resists the changes in pH. I see a winger. Yes, we wing it. Same as in Palworld. We just go inside a dungeon even though we don't have the trickster. A buffer is a solution that resists the changes in pH. And what does it have? It usually has it consists of an acid and a base, usually a weak acid and its conjugate base, and it helps maintain a stable pH. So again, what is a buffer? It is a solution that resists the changes in the pH, and what's it called? It is comprised of a weak acid and a conjugate base. What's an action potential? That's a good question. So an action potential is temporary. It's temporary and it is it's a rapid temporary streaming while reading, while running. That's three things at once. Of course, we are multitaskers in this universe. You have to. That's why I'm Isekai'd Mask Knight Empress Scientist. I forgot to introduce myself. Hi! Welcome to the stream. I'm Millennium, Isekai'd Mask Knight Empress Scientist, and today I will be studying while well, PH. I think that's a really good question. It's a part of an ID. It's an ID, a thing. I have to be able to answer this one. I'm just used to like saying, oh, that's the pH, but I can't exactly define it. Yeah, I just know that water is usually pH 7, and I can't exactly type right now for safety purposes. So if anyone can go to Google and paste it in chat, that would be beautiful. Thank you very much. Like a one-liner description of what a pH is, because that will help too. But yeah, what is an action potential? Right, it's a rapid temporary change that of the cell's membrane, and it occurs when a neuron or muscle cell is stimulated. This is important because action potential, if there is a neuro test or in the cardiac tests, yeah, neuro tests or cardiac tests, the professors might ask you, what is an action potential? So if they ask that, if Kakashi Sensei asks you, if Gojo Sensei will ask you, what is an action potential? You have to answer, it is a temporary change in the cell membrane's potential, and it's usually in a neuron or muscle cell. In chemistry, pH also referred to as acidity or basicity. It's the potential of hydrogen. Okay, thank you. So that's okay. It's how acidic or basic it is. Because I know that the higher numbers, like 14 is the super basic one, well, the lower numbers would be the super acidic one. So good job. What is the DNA? DNA. If Gojo will ask me, what is the DNA? Oh, this is helpful. I just have to think that Gojo Sensei is the one asking me, then we have to study, obviously. So if he asks, like, what's the DNA? It's deoxyribonucleic acid. Racking up strength, endurance, durability, and wisdom. Don't forget stamina, because hello, Lendor. Yells. Right now we are racking up strength, endurance, durability, wisdom, and stamina all in one stat run. We are multitasking to the maximum level. Yes. That's a really good way to put it. So deoxyribonucleic acid. Just think about Deoxys in Pokemon, the one in Mirage Island. That's DNA. It's based on DNA. It's a molecule that carries the genetic information of a cell. Oh, and I'm actually using the just chatting feature the just chatting template for the first time today. Whoop, whoop. Yeah. Yeah, how's the template? Is it sparkly? It's been there for a while. I just forgot it exists until I checked it earlier. So RNA, okay, we discussed what DNA is, but what is RNA? RNA is it's a single stranded nucleic acid involved in gene expression. So DNA carries genetic information, while RNA, like the middleman, it's a single stranded nucleic acid involved in gene expression, and it comes in several forms. For example, mRNA carries genetic information from DNA to the ribosome. How's the mic, by the way? DNA to the ribosome. tRNA brings amino acids during translation, and RNA forms the structural and catalytic core of the ribosome. So again, mic's alright. Okay, I can work on increasing the gain or something like that. Because right now this is, okay, that's nice that it's alright. I hope it's not picking up how loud the steps are. Oh, update so far, it says we've walked for 6 minutes and 30 seconds and the distance is 0.06. Wait, Wait, I'm waiting for the unit. What's the distance? 0.07. Miles or kilometers? I don't know. Well, but the number is 0.06. So, I'm gonna assume it's miles. I think it's miles. It should be labeled. So again, RNA has multiple forms. There's mRNA and tRNA. mRNA carries the information from DNA to the ribosome, and then tRNA brings amino acids during translation. rRNA would be the structural form of the ribosome. So we have MR and MTR. MRT. Anyone on the Philippine train? The trains in the Philippines right now, there's MRT. mRNA would be DNA to RNA to proteins. It's the carrier. Hello Lamji, welcome to the stream. I think this is the first time you popped up. There's the mRNA carries genetic information from DNA to ribosome. And then, oh, thank you for checking the mic. And then we have, what's the next one? rRNA. That is a structural catalytic unit of the ribosome. tRNA would carry the amino acids to build the proteins. See, they are very different parts. What is transcription? Mini review. Transcription, incredibly unique advice. It depends if you've read the rules and the description also. Yeah, but feel free to try, but we'll see. And if it gets filtered. What if transcription? It is the process where you transcribe mRNA from DNA. So you make RNA from DNA. It's DNA to RNA. And using a DNA template, obviously. It involves initiation at a promoter. Okay, it involves initiation at a promoter. If Gojo Sensei will ask me transcription, I have to answer. Transcription is the process where you use a DNA template and you make RNA. How? And he'll tell me, you want more if I can't answer. Well, I would answer that it starts, it begins with initiation at a promoter. Wait, what? Oh, I am not sure we can answer that. I am not familiar with business questions. My head is 60% Pal World or Pokemon, and the rest is, no, actually 50% Pal World or Pokemon, and then the other one is science, and maybe eating is somewhere in there too. So you mentioned today you found out when you were a baby, you were a baby diaper model for Pampers, and I asked for compensation and my parents said no. Is that okay? You might have to ask a lawyer. Pal World, OMG, I love Pal World, yes. And we are excited for the future summer update too, because right now we've conquered Faybreak, I think, except for the tower. But yeah, that is where we're at. What is transcription? Transcription, if Gojo Sensei asks you what is transcription, transcription is the process by which you make RNA from a DNA template. You usually start with you start the initiation at a promoter, and then elongation happens, and then you terminate it once you reach a stop signal. What is a gene? A gene is a sequence of DNA that encodes a functional product, usually a protein or a functional RNA. Again, what is a gene? A gene encodes a functional product, and it encodes usually a protein or a functional RNA. It would include promoters and enhancers in addition to the coding sequence. I don't have a PS5, unfortunately, so I don't know when I'll get a server. What is the central dogma of molecular biology? Okay, 4 hours ago we talked about the central dogma. What is it? So the central dogma is the process wherein you go from DNA to RNA to proteins. That's essentially it. It's the flow of genetic information. DNA, and then you transcribe it into RNA, and then you translate it into protein. Okay? Protein. Who is asking these scientific questions? Gojo Sensei or Kakashi Sensei will be asking the scientific questions. So that's how we're thinking about it. What is an enzyme? An enzyme is a biological catalyst that speeds up chemical reactions. So think if Minato from Naruto, for those who watch Naruto, if Minato asks you, what is an enzyme? You have to say an enzyme is a catalyst that speeds up chemical reactions without being consumed, alright? And it lowers the activation energy of a reaction, often showing substrate specificity. This is a learning / gaining stream. Yes, I wish we can mix this with, it might be possible with a Nintendo Switch, but I don't know if it's possible to play Power World at this state. It's not like while doing this one, so we'll have to see. So again, what is an enzyme? Kakashi Sensei is looking at you with a Sharingan right now. What will you say? What is an enzyme? An enzyme is a biological catalyst that speeds up a reaction. It works by lowering the activation energy of a reaction, and it usually shows specificity to a substrate. Okay, thank you, Kakashi Sensei. What is ATP and why is it important? It's the money system. So ATP, who else? If Koro Sensei from Assassination Classroom will ask you, what is ATP? Or else the moon will blow up. What will you say? No spoilers actually for those who watched it. But that's the question. ATP or adenosine triphosphate is the primary energy currency of a cell. It's the money of a cell. It stores energy in its phosphate bonds, and it fuels cellular processes such as transport, metabolism, and signaling. So what is ATP? Adenosine triphosphate. It is the primary energy currency of a cell. It stores energy and it's in the phosphate bonds, and it fuels the cellular processes. Okay? What is a protein? It's in chicken, it's in pork, it's in meat essentially. A protein is a polymer of amino acids linked by what? Peptide bonds. Again, if someone asks you what is, yes, the KFC, Jollibee, McDo, Wendy's, Chowking, all of those, you have protein. So what is protein? If you look at that Jollibee Chicken Joy, that one has protein, and you'll say, what is a protein? You know this. It is comprised of linked amino acids. How are they linked? They're linked by peptide bonds. Okay? What about its function? Its function depends on its 3D structure, which is determined by the amino acid sequence. So, think of a car. All of them kind of look alike. Some look alike. Generally, if you think of a car, you think of a small car. But the function of each car depends on its the structure inside, and it's determined by the amino acid sequence. So that even though the 5 cars might look the same, it depends. It depends on the Lego pieces, how fast each one is. Because car A might be the fastest because it has the better stuff inside. What is a neuron? A neuron is a specialized cell that transmits electrical signals in the nervous system. So again, what is a neuron? A neuron is a specialized cell. A neuron is a cell in the nervous system, and it helps transmit information. If someone asks, oh, why does it transmit information? action potentials. But wait, what's action potentials? It's essentially a temporary rapid change in the cell's membrane potential. How? It involves a depolarization. Yes, the brain emoji, if we have another slot, if ever, we could use it for the big brain emote. I'll use it sometimes too for as a thumbnail. While and I'm using different glasses right now to keep up with the trends. No, I'm just using it to change the vibe. It's like sunglasses. Yep. Oh, the heart rate monitor is there. So what is a protein? Was I doing a protein? No, I was doing neuron. What is a neuron? It really piques my mind how neurons does that in relation with the brain. Exactly. Transmitting electrical signals. Speaking of about neurons, it consists of a cell body. Yes. Glasses. Thank you. Speaking of neurons, it has a cell body. It has dendrites that receive input. And it has an axon that transmits the output. So again, if we have a picture of a neuron in front of us, we have dendrites and then the cell body and then the axon. Okay. Oh, point 18. I'm so curious if this is in miles or kilometer. Given how, I'm gonna think that it's in miles. I think it's in miles actually. Okay, so far at 0.6 speed, it says 8 calories, 18 minutes, 0.18 miles. Wow. What's a kilometer? Oh wait, that's a very familiar line from. Did I hear Aniji Sanji the library do that one? Hello Ichika, nice to meet you. Wait, let me see. Is it konbanwo? You look and voice is so great. Arigatou gozaimasu. You too. What brings you here to the stream? Right now why is my heart rate 121? Yeah, I came here from Japan because I wanted to make Ian Vtuber friends. Hi, no problem. We just keep on reviewing science as well. But what is depolarization? Oh, I think I have to explain. Right now we're reviewing science while we're on a treadmill. Why? Because it's possible. This is technology. This is reality, okay? What is depolarization? It is a shift in the membrane potential, and it is towards a more positive value, usually due to the influx of sodium ions during the initial phase of an action potential. We're gaining multiple stats. Yes, we are gaining multiple stats. Stream summary. Thank you very much. Yeah. We are doing, what was it? I just remember stamina, wisdom, and the other stuff. That's what we're doing. In terms of Isekai and gaming mode, we're increasing. It's like if I am the pal, we are using the potions and increasing the attack power. For example, if someone asks you what is depolarization, you have to be able to answer. It is a shift in the membrane potential towards a more positive value. Depolarization. Why? Because if a thing is polar, it's kind of negative. So if it's depolarized, it's becoming less negative, aka towards the positive end of the spectrum. If it's being hyperpolarized, it's becoming more negative. Hi, but do rest if you want to push the limit. Yes, but if the limit is too much, then rest. According to Mean Girls, the limit does not exist. A more positive value, that's a good question. Okay, so If, for example, it's about the membrane potential, for example, of the heart, um, like a general, like a muscle. There's a number, a normal number that it depends on the type of cell, like a strong one. Yeah, it depends on the type of cell or like muscle cell it is. But let's say you start from negative, let's say negative 40 millivolts. If the next line is saying that the membrane potential was that we are now depolarized, then it became, let's say, negative 30. So it became less negative, aka towards the positive end. Mm, and then next is, what is the sodium potassium pump? This is an important pump because it's an active transport protein that uses ATP to move a couple of things. Sodium potassium pump. Guess what it moves? Sodium and potassium. In what direction and by how much? Okay, it's 3 sodiums out and 2 potassiums in. 3 Na plus out, 2 K plus in. In out of what and into what? Into the cell. Out. It's pushing 3 Na out and 2 K plus in. That would help maintain the membrane potential of the cell. Where does that go? Yup, it goes either inside or towards inside the cell or outside. What is the nucleus? It's a membrane-bound organelle that houses the cell's genetic material. Okay? It contains DNA organized as chromatin. It has all the DNA. Very good. Yes. It houses. It is the house of your DNA, the genetic material. It's organized as the chromatin, aka the site of transcription and RNA processing. This is another term. Sometimes people, A plus. Sometimes people get confused, like, wait, DNA, wait, allele, gene, chromosome, chromatin. Okay, let me try and explain it. Right now I don't have my whiteboard, so just picture it in your head. DNA is the helix. If you remember the squiggly pole thing, the squiggly stairs, and then if you keep bunching it up, it becomes the chromatin, and bunch that more into the X, and then you get chromosome. So far we did DNA, chromatin, and chromosome. Now what's a gene? What's an allele? A gene is a specific part in it's a specific segment of a DNA. Yes, that one. Yeah, you squiggle it, the DNA, squiggle until you get the X. Perfect. I like the visuals. Thank you very much. This is our whiteboard. So if you talk about the gene and allele, a gene is a specific segment of the DNA. So instead of bunching it up, make the DNA into a super straight line, and a specific part of it would be a gene. So chat's the new whiteboard. Yes, it is the new whiteboard. Imagine if we have Neuro also, and then Neuro can talk. It's like, hi Neuro, what's the thing like that, and then Neuro would say Beetle, and Nero's she's really cute and funny. Alright, so what is the mitochondrion? What is the mitochondria? The mitochondria is the powerhouse of the cell. Yes, mitochondria is the powerhouse of the cell. Mitochondria is the powerhouse of the cell. Again, what is the powerhouse of the cell? The mitochondria. Mitochondria is the powerhouse of the cell. That one and CRISPR, clustered regularly interspaced short palindromic repeats. That's a thing we have to remember. It generates, there's an animation that shows how the DNA combine, if anyone Ooh, yeah, I think that might be a famous animation. It generates ATP via oxidative phosphorylation. Oh yeah, this one, the mitochondrion, is the powerhouse of a cell. It generates or makes ATP via oxidative phosphorylation. It also plays a role in apoptosis, calcium homeostasis, and metabolism. What is, yeah, whoop whoop, mitochondria? What is the endoplasmic reticulum? ER. It's not emergency room. In this note, it's the endoplasmic reticulum. It is the organelle involved in protein and lipid synthesis, because the rough ER has a gazillion ribosomes for protein synthesis, while the smooth ER is for lipid production and detoxification. So what is the ER? It is, let's see, the ER is the organelle involved in protein and lipid synthesis. The rough ER is for protein. Oh no, parts of the cell. Yes, it will always haunt you, but in a friendlier manner now. Because right now, imagine Koro Sensei is the one teaching it, and you have to assassinate Koro Sensei, or else. What was the plot of Assassination Classroom without any spoiler? Something like that. Good anime, by the way. Okay, so in the nervous system and membrane potential part, what is the resting membrane potential? It's the resting membrane potential is the electrical. Patrick, write that. Oh, good meme. Good meme. The resting membrane potential is the electrical difference between, well, across the plasma membrane of a cell at rest. Okay, again, what is the resting membrane potential? It's the difference, electrical potential difference between or across the plasma membrane of a cell at rest. It's usually negative 70. Okay, negative 70 what? Negative 70 millivolts in neurons. It's maintained by sodium potassium pump. So what is the resting membrane potential? It is the electrical potential difference across the plasma membrane of a cell at rest, and typically around negative 70 MV. Oh, sodium potassium pump. What does it do? 3 sodium out, 3 Na out, 2 potassium in, 3 Na out, 2 K in. Alright. How does the action potential propagate down an axon? So, this is a good question. Gojo Sensei might ask this. Kakashi Sensei might ask it. And Koro Sensei will ask it. Jiraiya Sensei will also ask it. How does the action potential move down an axon? When a threshold potential is reached, the sodium channels will open, and then sodium will go out. So influx, actually, sodium will come in, and then the cell will become more positive, aka depolarized. So this depolarization triggers the other sodium channels to open. So again, when the threshold potential is reached, let's say from negative 70 millivolts to maybe negative 60 MV, then it triggers the opening of a sodium channel. Sodium will come, a lot more sodium will come in now, and then that will lead it to, what's this called? That will lead the sodium to, so other sodium channel to open up, and then that's how they propagate the signal. After that, the potassium channels will open, allowing the potassium to exit the cell. So earlier, sodiums were coming in, sodium Na+. But now, potassium channels are open, potassium will go out, K+. That will lessen the positive stuff inside. So it will repolarize the membrane, aka make the membrane be less positive, aka more negative now. So that one continues as a wave down the axon. Note, this is different from the sodium potassium pump. Okay? The sodium potassium pump, that's one thing. Sodium channel is a second thing. Third, one would be the potassium channel. You have three gates we're talking about. Hello, racing. What is this about? Right now, we are talking about science while we're on a treadmill. That's essentially what's happening. That's why, and the heart rate monitor is just proof that we're all humans. Science, exactly. If someone says, "What are you doing?" It's for science. It's an experiment. I am the guinea pig. Alright, next. Why doesn't the action potential go backward? Good question. Wow, we reached 130. Why? Okay. Science and PE combined. This is exactly why it's isekai, essentially. Multitasking. Hello, hunted. Yes, welcome to the stream where we ask why doesn't the action potential go backward. It's because, yes, just that excited about science, I guess. Of course. Why doesn't the action potential go backward? It's because of the refractory period. After a segment of the axon fires, yells, "Welcome, was it irashaimase?" The Jollibee and studying. That's the mixture of it. Studying. Because of the refractory period, now do treadmill. Imagine if I do streaming until I walk 5 miles. I don't know if we can reach that today. We're barely 0.33. No, I'll keep going until I finish a certain set of questions. Who's gonna carry the logs? And the logs I'm carrying are the questions that I'm holding right now. It doesn't go backward. I know the little chat guys aren't appearing. Let me pause. How can I pause? Can I pause this one? It's pausing. It's pausing. No, there you go. Let me refresh it. 1 second. Let me pause it. Refresh, and then let's refresh this one. Refresh. I don't know why it's not working today. It should update. Let me continue. No! No, it works. Wait. No! Oh my gosh. Okay, there wasn't a pause button. It was only an on and off. Okay, what was the last number I said? 0.33 miles. Clip that, add that, note that, sticky note. It was 0.33 and I'll just add it now. It's okay. We have proof of purchase. Yes, we are. When the gamer posture is gone. 0.33. Thank you. I would pin it, but I am not in. I cannot pin it right now. Would have to pause it, and if I pause it, it erases the thing. Imagine there's no load save here. We have to finish the adventure. Why doesn't the action potential go backward? It's because we have the refractory period. After a segment of the axon fires, the sodium channels would enter an inactivated state. Take note, it's only inactivated. It's not a stopped state. So just pause. It's a pause. It's a pause compared to this mini walk pad. It's not pausing. It's only on and off. So it can't open immediately. That's why it's only a unidirectional propagation. So if once the sodium channels like they 0.33, yes, thank you. What would happen if the sodium potassium pump was inhibited for a long time? Well, yep. If they are stopped or dissipated, that would lead to the depolarization of the resting membrane potential. Because usually the sodium potassium pump would help maintain the let's say negative 70 millivolts, and but if you don't have the sodium potassium pump, then it might, let's say, go to the negative 30 millivolts, and that would be bad. Why? Because it would impair excitability, and it could lead to cell swelling and eventual cell death due to osmotic imbalance. So which chapter we're learning? I assume organic chemistry. It's I think it would be molecular and cellular biology. That's where we're at. It's a mix of molecular and cellular biology and biochemistry. So yeah, you want your sodium potassium pump to keep working, or else you would get cell swelling and eventually cell death. The cells won't be working if that's the case. Anime, pun, wink. Okay, what is a promoter? A promoter, we talked about this. A promoter is a DNA sequence upstream of a gene. Yes, it will be slowly dying. Eventual cell death. A promoter is a DNA sequence upstream of a gene that recruits RNA polymerase and transcription factors to initiate transcription. It's essentially an area in a gene where transcription starts, and that is where your it's not the silencer. Silencer is the section of the gene. It would have specific transcription factor activators, that one. And in prokaryotes, that would be the tata. It would be TAT, AAT, and negative 35 would be the TTGACA. In eukaryotes, that would be the tata box, and it would require what? The general transcription factors like TF2D. Okay, mini review. What is the promoter? Promoter is a specific area of a gene where you start the initiation for transcription, and it will usually have the tata box in the eukaryotes. Why the tata box? TATA, because those would be connected only by 2 bonds, so it's easier to break compared to the GC combination, which has 3 bonds. As you can see, it's easier to break 2 bonds compared to 3. Okay? So, the question would be next would be, walk me through transcription initiation in eukaryotes. Transcription factors like TF2D would bind the tata box in the promoter. It binds the tata box in the promoter. Okay, that's a cool spelling of okay. That's noted, clipped, sticky noted, and pinned. The transcription factors like TF2D would bind the tata box in the promoter. Define prokaryotic cell. No, we can't forget it. Prokaryotic cell would be, it's not the eukaryotic cell. Prokaryotic cells are also less complicated and in a way easier to work with compared to eukaryotes. For example, humans are on the eukaryotic cell division, so that's already saying something. So TF2D binds to the tata box in the promoter. Then you assemble the pre-initiation complex with the RNA polymerase 2, and then you have the TF2H, aka the helicase, which unwinds the DNA, and you have RNA pol 2, which begins RNA synthesis at the +1 site. Okay? Then you have the phosphorylation of the CTD tail of the RNA pol 2, which would allow promoter clearance. So again, one more time. walk me through transcription initiation in eukaryotes. Gojo Sensei is asking, tell me about the you, like that. Okay, so transcription factors like the TF2D reverse bind, and then the pre-initiation complex would happen, and then the TF2H would split the DNA, the DNA helicase. I mean the intertwined one. RNA polymerase 2 would then sit and start. Begins. RNA pol 2 specifically, don't forget. How is RNA processed after transcription? Well, you have splicing, you have the 5' cap, and then you have the 3' poly A tail. The 5' cap and poly A tail would all serve as like protective measures. 5' capping would be you add the 7-methyl guanosine to the 5' end. 7-methyl guanosine. Splicing, introns are removed, exons are kept. The way I would remember this is EXO. Listen. Okay, it's a Kpop one, but you would keep exons there. And then 3' poly A tail. You add a poly A tail after cleavage near the polyadenylation signal. AAU. That one. Why is the 5' cap important? Good question. Well, if it's missing, there's nothing to protect the mRNA from exonucleases, because it protects mRNA from exonucleases. It would help it for export, and it's required for ribosome recognition. So without it, monkey, yes, AA, wait till you hear the codons. There's funny letters there too. The 3 stop codons would be uwag, uga, and uaa. Do they ask the diagram of axon at your college? I assume they did ask that in college, and I would think that they ask it after college as well. What is the difference between transcription and replication in terms of enzymes and products? Transcription uses RNA polymerase to produce. What's the question one more time? What is the difference between transcription and replication in terms of enzymes and products? Hello, Sheriff. Welcome to the stream. We are doing science. This is actually science combined, because we're reading science, and we're also doing the science. Yeah, the cells are working. The cells at work. The cells are working. We are increasing our stamina and wisdom and attack and defense and health, all in there. So what's the difference between transcription and replication in terms of enzymes and products? Okay, transcription would use RNA polymerase. Big words scare me. Visual, I learn extremely fast. Verbal, my mind just kept backing out. Yeah, that's why pictures help. I try to paint a picture if I can only use words, because sometimes there's no whiteboard, like this situation. So again, transcription would use RNA polymerase. It would be from a DNA template into RNA. DNA template, and then RNA polymerase, and then you make RNA. That's transcription. Only copies one strand. Which layer surrounds the axon? Layer? Sheath? Is it the sheath? Were you asking about the sheath? Yes. Awesome. Nice one, Zumi. Okay. So RNA transcription, you only copy do one strand. Replication uses DNA polymerase on both to produce a complementary DNA strand, and you try to copy both strands. The only thing is you have the lagging strands as well, because you're going in a different direction. Transcription is selective and regulated by promoters, and the replication is semi-conservative and it occurs once per cell cycle. GG, you might be the prodigal straight A student. Hopefully. Wait, what's the definition of a prodigal? Just to make sure. We want the A student at the minimum. Why is ATP a high energy molecule? Okay, ATP has high energy phosphoanhydride bonds. Ooh, nice one. Thank you very much, George. We have another gifted now. Whoop whoop. That's we'll keep the speed. You know what? For that one, I'll increase the speed by 0.1. Oh no, it did it by 0.2. What's happening? Oh, it only does 0.2 each time. No, from 0.65. Yeah, let's do it. 0.6 to 0.8. Let's go. Yeah, that's a new add one. Remember, ATP stands for adenosine triphosphate. Adenosine. Thank you very much. Keep the questions going. That's one. Yeah, 0.2. That's a new. Okay, I'll add that as a rule. That would be funny. Each new and gifted membership would add 0.2. 0.2 miles each one. Says no ones, it's only twos. Yeah. And now they always juggle definition and full form. I know. Yeah, the new added rule now for every new or gifted sub. Boom, add 0.2 to the speed. Right now we're at 0.8 miles per hour. At this point, we might be able to walk to Japan, and it will only take us about 100 years. It's alright. We'll get there. Okay, what was the question? Why is ATP a high energy molecule? ATP has high energy phosphoanhydride bonds due to charge repulsion between phosphate groups. Okay, what again? It has high energy phosphoanhydride bonds between phosphate groups. So if you break them, the heart rate is responding to the 0.8. The asthma is going. You have charge repulsion between the phosphate groups. That's why you have higher energy. Is really helpful, by the way. The other day, 30. What's that? We did 30 jumping jacks. So healthy. So healthy. I have to. I'll put the updates in the community tab. So far, 0.33 miles plus the current one, and then the 30 jumping jacks. 2025. Road to Usain Bolt level. No, road to One Punch Man level. In oxidative phosphorylation. Oh, no. How is ATP generated in the mitochondria? What is the mitochondria? It's the powerhouse of the cell. In oxidative phosphorylation, electrons go from NADH and FADH2, and they pass through the electron transport chain in the inner mitochondrial membrane. Yes. Is that the road to bulking or road to healthy? That's a good question. I just want to live longer, at least. That's the goal in life. To just survive. That's why. That's the goal. To live long enough for Sword Art Online to be a reality and use a 3D model at some point. Yeah. What's the next one? Oh, electrons from NADH and FADH2, they pass through the ETC, the electron transport chain, in the inner mitochondrial membrane, pumping the protons into the intermembrane space. That's a good question. I checked them out, the 3D model prices, and I'm afraid I may have to sell both my kidneys for that one, so that may be out of reach yet, or I'll have to do a couple of, what's that called, member-a-thons or something for that one. So yeah, but my right now I like music videos more, so that's what I'm making. And then the ultimate goal would be, hopefully in this lifetime at some point, to, if I can get like a 3D model, that a custom 3D model that looks like the one I'm using, and use it as a thing in maybe Beat Saber, and live the dual swords, the dual sword wielder, like user there. So that would be fun. And there's also Project Aincrad that I would like to try. I think it's a project, fan made project by some people who really liked Sword Art Online, and they actually made the world there. So that's why, yeah. But like right now, I check, I'm like, I think I'll need at least not just 2 kidneys to sell at this point for that. So I'll keep trying. And that's why the the gifteds and the members would help. It'll come for sure, just a lot of grind. Just don't go the the Chibidoki route from kawaii to extreme chaos. Yes. When I donate 1 kidney, no one bats an eye. When I donate 10, suddenly people have a problem. I know, it's like, it's a funny issue. But yeah, so far the main issue is, how is ATP generated in the mitochondria? And we know that it's usually in the electron transport chain. Why? Because it goes from the electrons from NADH and FADH2 will be passed on through the chain, where in the inner mitochondrial membrane, and the final acceptor would be, I forgot, what's it, oxygen or something? Wait, I forgot which one. What's the final acceptor? But you pump the protons into the into the intermembrane space. So it essentially powers the ATP synthase, which synthesizes ATP from ADP and PI. Dialysis will be more complex. Good. Good catch. That's true. I think if you don't have kidneys anymore, it would be harder to dialyze a non-existent kidney. So that's why it's more complex. What is oxidative phosphorylation, and where does it occur? It occurs in the mitochondria. Where specifically? In the inner mitochondrial membrane. It's the process of what? Oxidative phosphorylation is what? It would be the process where you remake ATP, aka ATP synthase, and it's powered by the proton. It's powered by the transfer of electrons via the electron transport chain. So, hi, no problem. Thank you very much. Yeah, this is where this messed up. Yeah. Lesson learned: don't sell kidneys. Don't sell all kidneys. Sell one and half of the other. Maybe, but don't actually, no. Just keep both kidneys healthy and intact. Hopefully. 07. Hopefully we have the salute emote at some point as well. But yeah, thank you for dropping by. What would happen to ATP synthesis if the inner mitochondrial membrane was leaky? Very, very good question. It would dissipate the proton gradient, and you can't remake all of the ATP that you actually need. Yeah. Walking through the info from DNA to protein, that's finished. How does the cell sense and respond to low glucose levels? Well, it triggers. So if you have low glucose level, aka you didn't eat, you forgot to eat. You've just been studying for 8 hours straight. You forgot to set an alarm for breakfast and lunch, and now it's 4 p.m. and you're very hungry and your head hurts. So low glucose levels would trigger increase in glucagon, and the glucagon will activate adenylate cyclase. Again, glucagon would activate adenylate cyclase in hepatocytes, and count levels would rise, which would activate PKA. So again, glucagon activates adenylate cyclase, which would and count levels rise. Adenylate cyclase and count levels rise, which would then activate the PKA. PKA phosphorylates some of the other enzymes, which promote what? It would promote glycogenolysis and gluconeogenesis. Essentially, glycogenolysis would be breaking down of glycogen. That's why it's lysis. Glycogen lysis breaks down glycogen, and it also activates gluconeogenesis, aka making the glucose to increase the blood glucose, because we started with you don't have enough glucose. Why do we need buffers in the blood, and what's the main one? This is a good question. Why do we need buffers in the blood, and what's the main one, and what would happen if it failed? So buffers, that's the first question earlier. What are buffers? Buffers maintain the pH. Reminds of the lysosome chapter, because they are the suicide cells. Very, very nice. It is. They are indeed the suicide cells. We need the buffers in the blood to maintain the pH level, because you need it for enzyme function and protein stability. And the main buffer is the bicarbonate system, because you have carbon dioxide plus water, carbon dioxide plus water, tubig, carbon dioxide plus water into H2CO3, and it becomes H and HCO3. If the system fails, acidosis or alkalosis can occur, and it would lead to a life-threatening enzyme dysfunction and altered ion distribution. And how does feedback inhibition regulate a metabolic pathway? It occurs at the end of a pathway. A therapist might have poor lysosome. Yeah, it needs a therapist. Feedback inhibition occurs when the end of a pathway inhibits an upstream enzyme, often the first committed step. So for example, these are some words. So you have isoleucine biosynthesis from threonine. Isoleucine inhibits threonine deaminase, so it would prevent overproduction. Okay, update. One of the sets of questions, it's now finished, and right now we are at 0.8 stream. Hello, found you through recommended from Palworld. What a great stream. I just wanted to say glycogen is really fun to say. Hello, Squishy. Wait, for real? How does the recommendation from Palworld work? I didn't know that they had that one, but I do keep on playing Palworld. It is, and I have a couple of shorts coming up for that one too. Yes, more Palworld. Just recently we built a house. After 6 months, I finally have a house in Palworld that has 4 walls, the floor and the ceiling. So that's a very big upgrade. At level 60, by the way. That's Palworld content acquired. Whoop whoop. It's Palworld stream coming next Saturday. EST. It has a waiting room. But yes, next set. DNA topology questions. Okay, but so far it was 0.33 earlier, and now we are at 0.3. So add that. It's 0.63 miles now. 0.63 miles. Whoop whoop. Beautiful. Alright, pin that somewhere. Okay. DNA topology question. Can you describe the structural features of bDNA and how they relate to its function? YouTube recommends based on prior viewings. Oh, really? Thank you very much. Yeah, it takes a while to make a house. I would like to make a Sakurajima castle at some point. But yeah, thank you for letting me know. Like that's really nice. It's like it among the sea, in the sea of some YouTube videos. At least it went to someone who also watches Power World. So thank you for coming by. And glycogen is indeed a fun word to say. Yeah. Okay, so describe the structural features of baby DNA and how they relate to its function. So BDNA is it's the canonical right-handed double helix. Canonical. The author said so? Okay. It's approximately 2 nanometers in diameter with about 10.5 base pairs. Okay. So that's the BDNA. What is the significance of DNA anti-parallel orientation and the grooves? Okay, if good question. Right now, so we finished the overall. We're using all the questions on my notes, and if as a book basis it's Albert's, but I'm using my notes questions and the internet questions. Speed is at zero point 0.8 miles, but it was at 0.6 earlier, and then when a gifted member came in, I was like, oh, let me increase the speed each time a new member joins. So that's how it's now at zero point 0.8. And yeah, it would be really funny if it was suddenly like plus 10, so like 10 times zero point 0.2. It's like, whoa. And so that means I'll just click it 10 times. And I may have to run if that happens, but that's why we're testing the limits of what's possible. Yeah, so as per your question, it is on the DNA topology chapter in a way. Speed is 0 0.8. Currently, as of this moment. What's the significance of DNA's anti-parallel orientation and grooves for molecular interactions? The anti-parallel orientation ensures that the base pair forms optimal hydrogen bonds and that it would fit within the double helix. Okay? The arrangement allows enzymes like DNA and RNA polymerase to read and synthesize them. What is the role of hydrogen bonding and base composition in DNA stability and melting temperature? Oof. We talked about it. Yeah, okay, I see. Cool. Thank you for summarizing. I did that too when I talk. Yeah, that's why it helps just repeating the words. GC pairs have 3 bonds, so it's harder to destroy in a way. AT pairs only have 2. Therefore, regions rich in GC content have higher melting temperatures than AT-rich regions. So that's why. TM reflects the temperature at which, this is just melting temperature, at which half of the DNA is denatured. How do changes in twist, ride, and linking number explain DNA supercoiling? Good question. So linking number is essentially how many times one strand wraps around the other. It's usually fixed unless the DNA backbone is broken. Twist is just the number of turns. Ride is the number of supercoils or the DNA's spatial coiling. Spatial coiling. What's the equation? It's link equals twist plus ride. Link again, how many times it wraps around. Twist is how many, the number of helical turns. Ride is the number of supercoils. And it would balance out each other. How does DNA supercoiling affect gene expression and DNA accessibility? So supercoiling influences the ability of proteins to access DNA, and negative supercoiling promotes separation because it's negative, and then it would aid the transcription initiation because the factors can come in. What else? Positive coiling. If unrelieved, it would hinder transcription. But anyway, I think let's summarize it. I'll wait for it to show the distance right now. It's at 0.37. 0.37 plus 0.33, it's 0.7. We did it's 0.7, right? I think that one's good. Because right now, I need to rest. But let's pause this one. Yes. Or should I reach one? Oh my god. Okay, fine. Should I wait for another 0.3? Okay, let's see. Now I'll pause it now. Then let's add it to the next one later on. Where's the? Okay, paused. Okay, let's add it. 0.33 and 0.7. It depends if you want to rest or keep chugging. Yeah, I think I'll rest. It's been an hour and 15 minutes. I have not been hydrated. I was just walking and reading. But anyway, I think that might be all for today so far. And this was funny. I didn't think that it would work. That I had to move the treadmill to be in front of my laptop for this to work. So that's why. So thank you very much for watching this mini stream. And I'll try to fix the mini bouncy thingies, because normally if you saw the other streams, there would be bouncy, all of these in the screen in front. Each chatter would get that one usually. So I don't know why it's not appearing right now for each one. I'm just glad at least the custom CSS works, because if you see, if I type, it would the emojis also work on it. So see, and then the coder actually made sure that the knights and the crowns are in there as well. But yes, thank you very much for coming and to this stream, and please, if you have time, come back and watch more. Bye bye.